Hello students, how are you all? I am Gurmeet Singh and welcome you to CREATA classes and also welcome to our complete series on trigonometry for class 10 student. In this lecture or in this series, we will cover all these lectures using the power of visualization. You will love our unique way of teaching. Apart from this lecture, we are also having a complete PDF of the formula and concept list. Check out the link in the description. And we also have the cues related to the various trigonometric questions. To check the level of your understanding of the concept, check the link in the description. And especially in this lecture, we will cover the exercise 8.3, question number 1 to question number 3. So if you want to practice more questions, check out the link in the description. We are having a quiz related to trigonometric questions. Check the link in the description. So without taking any further time, let's start with this lecture and best of luck, and here is the lecture. Before taking down the exercise 8.3 questions, you should know which formulas will be applicable. Firstly, these three trigonometric identity formulas will be applicable. The first is the relation between sine and cos, that is sine square theta plus cos square theta is equal to 1. The second formula involves the relation between tan and sec, that is 1 plus tan square theta is equal to sec square theta. Third formula involves the relation between cot and cosec, that is 1 plus cot square theta is equal to cosec square theta. Especially I have mentioned the relation between the trigonometric ratios because this will be used in solving the questions. You have to know which trigonometric identity have to apply based on the relation between the different trigonometric ratio. As we take down different questions, you will understand it more. Okay. Further, the other type of formulas that will be used is these formulas. Tan theta is sine theta upon cos theta. Cosec, sec and cot are the reciprocal of sine, cos and tan respectively. That is, cosec is 1 upon sine, sec is 1 upon cos, and cot is 1 upon tan. We can also rewrite this in the opposite format, like sine is equal to 1 upon cosec, cos is equal to 1 upon sec, and tan is equal to 1 upon cot. Based on these formulas and the basic logic, we will solve all the questions. Apart from these formulas, you should also know the basic algebra formulas. The square formulas, the cube formulas that will also be used in solving the questions. Basically, the square formulas are frequently used, so you should know them. So these are the formulas based on which we will solve the exercise 8.3. Let's start with the question 1. Express the trigonometric ratios sin A, sec A and tan A in terms of cot A. In this question, we have to find the value of sine, sec and tan in terms of cot. Let's see. Firstly, let's start with sine. Here we have to express the value of sine in terms of cot. For that, let's take the third trigonometric identity equation, that is 1 plus cot square theta is equal to cosec square theta. Here our trigonometric angle is angle A. So let's replace theta with angle A. We got 1 plus cot square A is equal to cosec square A. We have taken this equation because we have to express sine A in terms of cot A. We need sine and cot. In this equation, we are having cosec and cot. And what is cosec? Cosec is reciprocal of sine. So basically, this equation involves sine and cot both. So this equation will be helpful to us. Let's see. Let's replace cosec with 1 upon sine. We got 1 plus cot square A is equal to 1 upon sine square A. So sine square A will be equal to 1 upon 1 plus cot square A. So we got sine A as root 1 upon 1 plus cot square A, that is 1 upon root of 1 plus cot square A. So basically we have converted or expressed sine A in the term of cot A. So we have done with the first part, that is sine A. Okay. Let's take down the second part, that is sec A. We have to express sec A in terms of cot. We will use our second trigonometric identity equation, that is 1 plus tan square theta is equal to sec square theta, which is basically 1 plus tan square A is equal to sec square A. We have to express sec in terms of cot. That's why we have taken this equation. This equation involves sec and tan. And what is the relation between tan and cot? Both are reciprocal of each other. Cot is equal to 1 upon tan and tan is equal to 1 upon cot. So by using this equation, we got sec and cot. These two trigonometric ratios we required. Let's see. Let's replace 10 with 1 upon cot A. We got sec square A is equal to 1 plus 1 upon cot square A. Let's take the LCM as cot square A. We got cot square A plus 1 upon cot square A. Further, sec A is equal to root of cot square A plus 1 upon cot square A. Let's take cot square A out of the root. We got sec A as root of cot square A plus 1 upon cot A. That is the answer. We have expressed sec in terms of cot. Got it? The last one, we have to express tan in terms of cot. This is a direct relation. We know tan and cot both are reciprocal of each other. So tan A is equal to 1 upon cot A. Very simple. Okay. So we have done with the question number 1. Let's move to question number 2. Question number 2 is write all the other trigonometric ratios of angle A in terms of sec A. In this question, we have to write all the trigonometric ratios like sine, cos, tan, cosec, sec and cot in the term of sec. All the trigonometric ratios in the terms of sec. So let's approach this question. Basically, the concept that we will use is that we will only express sine and cos in terms of sec. Once we got sine and cos in terms of sec, we can easily find the value of tan as sine upon cos. Further, we can find the value of cosec as reciprocal of sine. That is, cosec is equal to 1 upon sine. Sec is already expressed in the terms of sec. And cot is the reciprocal of tan. That is, cot is equal to 1 upon tan. So basically, we will find only the value of sine and cos. Other trigonometric ratios will follow automatically. So let's proceed and let's start with the value of sine. We have to express the value of sine in terms of sec. So here we need a trigonometric identity equation which is having both sine and sec. If you refer, we are not having any of the trigonometric identity which is having both sine and sec. But if you observe the first trigonometric identity equation, it is having sine and cos. And what is the relation between cos and sec? Both are reciprocal of each other. Basically, this equation is a relation between sine and sec in the indirect way. Let's see what I am talking about. Here the equation is sine square A plus cos square A is equal to 1. We can rewrite it as sine square A is equal to 1 minus cos square A. And we know cos and sec both are reciprocal of each other. So we can write cos A as 1 upon sec A. That is 1 minus 1 upon sec square A. Let's take the LCM as sec square A. We got sec square A minus 1 upon sec square A. So we got sine A as root of sec square A minus 1 upon sec square A. Let's take sec square A out of the root. We got the final expression as sine A is equal to root of sec square A minus 1 upon sec A. That is the expression of sine in terms of sec. Got it? We got the value of sine. Let's find the value of cos. We have to express cos in terms of sec. How we will do that? That is a direct relation. We know cos and sec both are reciprocal of each other. Sec is equal to 1 upon cos and cos is equal to 1 upon sec. So we got cos A is equal to 1 upon sec A. That is the answer. We have expressed cos in terms of sec. Easy? Now we got the value of sine and cos. Now we can easily find all the other trigonometric ratios. The same principle we have used in remembering the trigonometric ratio table, the same principle we will use. You can take it as a revision. Let's find the value of tan. Tan is sine upon cos, so tan A is equal to sine A upon cos A. And we have calculated the value of sine and cos. Let's put it into the equation. Sec A and sec A will cancel out. We got our final answer or the expression as root of sec square A minus 1. That is the expression of tan in terms of sec. Got it? Very easy. Let's find cosec in terms of sec. We know cosec is the reciprocal of sine, so cosec A is equal to 1 upon sine A. And we have already calculated the value of sine. Let's put it into the equation. We got the final expression as sec A upon root of sec square A minus 1. That is the answer for cosec A. Okay. Sec is already sec, so we will not take that. Let's go for cot. We know cot is reciprocal of 10, so cot A is 1 upon 10A, and just now we have calculated the value of 10. Let's put it into the equation. We got cot A as 1 upon root of sec square A minus 1. That is the answer. Got it? We have expressed all the trigonometric ratios in terms of sec. So we have done with the question number 2. Let's move to question number 3. Students, a important thing for you, check the description for the PDF of the complete formula list and also the link to the quiz. Use the formula list to brush up the concept before the exam and the quizzes to check your preparation before the exam. The link to both the formula list and the quizzes are given in the description. Check it out. So let's back to the lecture. Choose the correct option. Justify your choice. This question is having 4 parts and 4 options are also given against each part. Let's take one by one. Let's take the first part, which is 9 sec square A minus 9 tan square A. It is having 4 options. Let's take down this question. Here we have to find the value of 9 sec square A minus 9 tan square A. Let's take 9 as common. We got 9 times sec square A minus tan square A. If you refer the second trigonometric identity equation, that is 1 plus tan square theta is equal to sec square theta, which can be written as sec square theta minus tan square theta is equal to 1. That is sec square A minus tan square A is equal to 1. So the term sec square A minus tan square A will be equal to 1. We got the answer as 9. Option B. That is 9 is the answer. Got it? The simple one. Let's take the second part. We have to find the value of the expression 1 plus tan theta plus sec theta into 1 plus cot theta minus cosec theta. We know tan theta is sin theta upon cos theta, and we also know sec theta is 1 upon cos theta, and cot theta is cos theta upon sin theta. Cot is basically the reciprocal of tan. Tan is sin upon cos, so cot will be the reciprocal, that is cos upon sin. And cosec is the reciprocal of sin, that is 1 upon sin theta. Let's put all the value. In the first expression, let's take the cos theta as the LCM. In the second expression, let's take sin theta as the LCM. We got this expression. Here, let's put sin theta and cos theta in the bracket in both the terms. Here, can we compare this with a plus b into a minus b? Are you able to observe this? Here sin theta plus cos theta is a and 1 is b. So this is a plus b into a minus b, which is a square minus b square. A is a complete term, sin theta plus cos theta. So a square will be sin theta plus cos theta whole square minus b square. B is 1, so minus 1 square, that is 1. Got it? We have simply applied the formula of a plus b into a minus b. So let's open the square. Sin theta plus cos theta whole square, which will be sin square theta plus cos square theta plus 2 sin theta into cos theta. Simply we have opened the square. Sin theta plus cos theta whole square, or a plus b whole square, which is a square plus b square plus 2ab. Here sin square theta plus cos square theta, this is resembling the first trigonometric identity equation, which is sin square theta plus cos square theta is equal to 1. So let's replace it with 1. 1 minus 1, this will cancel out. We got 2 sin theta cos theta upon sin theta into cos theta. So sin theta cos theta will cancel out. We got our answer as 2. So 2 is the answer of this question. That is option C. Got it? So the approach that we have used, by observing the expression, we are having tan and sec in the first term and cot and cosec in the second term. If we observe tan and sec in terms of sin and cos, tan is sin upon cos and sec is 1 upon cos. Both are having the denominator as cos. While if you observe cot theta and cosec theta in terms of sin and cos, both are having sin theta as a denominator. So this approach you have to use. This you have to think while observing the given expression or the given question. The more question you will try, the more you will be easily able to identify this aggregation. That is the next step that you have to proceed with. Okay, so try as many questions as it is possible. So we are done with the part 2. Let's move to part 3. Sec A plus tan A into 1 minus sin A. So here this is the expression. The same philosophy we can use here also, like sec and tan in the term of sin and cos. It will be 1 upon cos for the sec and sin A upon cos A for the tan. So both will be having the denominator as cos. So this we will use. Let's see. Let's take the LCM as cos A. We got 1 plus sin A into 1 minus sin A upon cos A. Again, we got the expression 1 plus sin A into 1 minus sin A. This expression is resembling A plus B into A minus B, which is A square minus B square. This formula will be frequently used in the trigonometric identity question. So you should know this and you should observe how you can implement this formula. Let's use the formula. It will be A square minus B square, that is 1 minus sin square A. And if we apply the first trigonometric identity formula, that is sin square A plus cos square A is equal to 1. From this we can get 1 minus sin square A is equal to cos square A. Let's replace it. Here cos and cos will cancel out. We got the answer as cos A. So the answer of part 3 is D, that is cos A. So what formulas we have used to solve this question? Firstly, we have used sec A as equal to 1 upon cos A and tan A as equal to sin A upon cos A. Next, we have used the formula of A plus B into A minus B, the basic algebra we have used. Lastly, we have used the formula of trigonometric identity, the first formula sin square A plus cos square A is equal to 1. So these basic formulas we have used. Note that the basic algebra expression, that is A square minus B square, A plus B whole square, A cube plus B cube, all these basic algebra expressions you should know. These basic formulas will really help you solve the question. Okay, got it? So we have done with the part 3. Let's move to part 4. 1 plus tan square A upon 1 plus cot square A. We have to find the value of this expression. Let's do so. Here 1 plus tan square A is equal to sec square A. How? We have applied the second trigonometric identity equation, the second formula. 1 plus tan square theta is equal to sec square theta. So 1 plus tan square A is equal to sec square A. Similarly, the denominator expression 1 plus cot square A, it is the third trigonometric identity equation or the formula, which is 1 plus cot square theta is equal to cosec square theta. So we got cosec square A in the denominator. And what is sec? Sec is a reciprocal of cos. And what is cosec? Cosec is the reciprocal of sine. So let's replace sec A with 1 upon cos A and cosec A with 1 upon sine A. We got sine square A upon cos square A. And what is sine upon cos? It is tan A. So we got the answer as tan square A, that is option D. Got it? We have done with the part 4. So we have done with the question number 3, all the 4 parts. So students, that's it for this lecture. Hope you have enjoyed our creative way of teaching. If you have enjoyed this lecture, if you have gained anything out of this lecture, please like, share and subscribe to our YouTube channel, that is CREATA Classes. We add creativity to the learning. And note that this lecture is part of the complete series on trigonometry for class 10 student. The link to the other lectures are given in the description. Check it out. And apart from this, also check out the PDF of the complete formula and concept list and also the quiz related to trigonometric questions, where you can check the understanding of the trigonometry and the questions. So that's it for this lecture. Bye for now. Best of luck for the exam you're preparing for and have a great day. Bye.